Okay. Good afternoon, sir. And today we'll be presenting about the effects of natural light in architecture. So in my group, it's just me and Mariam Zimna. So what is natural lighting? Natural lighting is known as daylighting, and it's also a technique that efficiently brings natural light into your space using exterior glazing. Some of the examples of exterior glazings are windows and skylights. Natural lighting also helps reduce the need of artificial lighting, as well as it also helps to save energy. Natural lighting in your space also helps to increase health and comfort levels for building occupants. So where does natural light come from? Natural light usually comes from three main sources, which are direct sunlight, external reflection, and internal reflection.
Good.
Okay, so for the sun part of Dubai, the sun path refers to the daily and seasonal arc-like path that the sun appears to follow across the sky as the Earth rotates to orbit the sun. The United Arab Emirates' moderate northern position in the hemisphere has an impact on the timings of dawn and sunset. Although not as severe as in the US, there is still a significant difference.
So in Dubai, summer days are long, whereas winter days are brief. June has the longest days with up to 140 hours of daylight. Winter, on the other hand, has the longest dark nights, which is opposite from the southern hemisphere. A night in Dubai in December lasted over 14 hours, and in these days, the sun in Dubai rises at 6:20. The early sunset at 5:47 makes the day currently a bit too short.
All right, good.
Yes. So as you can see in here, even the days are getting shorter. These months until these
Data,
till
okay.
6 months it's getting shorter, and then uh, the next slide. So the passage of the sun over the horizon at any particular point is the first thing to comprehend. Natural daylighting, passive heating, solar energy generation, and even natural ventilation may all be benefited from a structure constructed with these aspects in mind. However, care must be taken to ensure that these potential benefits do not compromise building efficiency by causing glare or overheating. So the phrase building orientation typically refers to the direction in which the facades face. Regardless of the climate, it is preferable to have the main facade face north or south rather than east or west. Even in the summer, the sun is low in the sky in the east and west, making shade impossible. North-facing windows, on the other hand, receive direct sunlight only during the summer, but a south-facing facade may be readily shaded by modest overhangs due to the sun's high angle. Thank you.
The building orientation, can you go back the last slide just now? The building orientation, that should be, I mean the small diagram, that should be one full page diagram. You know what I mean? The building orientation, the big title there. Then you have a north, west, east, and south, and then the sun. That one should be one full page. Can you zoom into that, or copy and then paste to the other side of the other?
Yeah, sure.
Yeah, can you do that? Yeah, I think zooming in is not enough. Maybe you copy this one and then paste to the other slide, and then you make this one bigger. Yes, you can zoom, you can stretch further. Because there is important writing there. There is, if you can find a way to see the writing. Still cannot see.
Yeah, it's been blurry.
Okay. This data didn't, your studies didn't show the Dubai location, latitude, longitude, distance from the sea, and then general temperature is sun path. No, slide number 4. Can I go back to slide number 4? Is talking about dusk and dawn, but there is no information on the temperature, night and during the day and during the night, because this is also effects from the natural light, right? Effects from the sun. Yeah. So the temperature is also should be included in this. Okay. And then you're also missing at least some introduction of the Dubai. What is Dubai is a city of United Emirates, Arab, UAE, United Arab Emirates. So also it's part of the introduction. Then the what else? Differential lighting. And then there is no example of building like house or build the other bigger buildings. There should be at least some example of buildings. Otherwise, it's only diagrams. There is we architects, we should have example with real diagram, no real picture. That's how we study. Then how the natural light in house is different from natural light in office or in the school, for example, in Dubai, you know?
Yeah.
Okay. That's my comment. Okay. Hope you can add those info, and then for the next presentation, right?
Yeah.
Also, please include back the Dubai information of Dubai. Okay.
Yeah. Okay.
For example, we'll talk about that after these 3 presentations. Okay. For the next group, let's go. Okay.
It's Brian Group. Yeah.
Yep.
Thank you, sir.
Nashwin and Mariam, good. But need more info.
Yeah. Okay. Thank you, sir.
Welcome. Okay, so next group. Jack, Damien, and Brian, right?
Yes, sir.
Okay, we can start.
Good morning. Our group is presenting about the effect of natural light in architecture in Beijing, China. First of all, Beijing is the capital of China. The center of Beijing is located at 39 degrees north latitude and 116 degrees east longitude. Besides, the annual average sunshine hours in Beijing is between 2,000 and 2,800 hours. The maximum sunshine hours are in spring, about 350 hours of sunshine per month. Summer is the rainy season. the number of sunshine hours is reduced, and the monthly sunshine is about 2,300, 230 hours. Although there are not as many sunshine in autumn as in spring, it's more than in summer with 230 to 245 hours sunshine per month. Winter is the season with the least sunshine hours of the year, and the monthly sunshine is less than 200 hours, usually 170 to 190 hours. Next. This is the sun path diagram in Beijing, China. From this diagram, we can see that the upper line is the June solstice. June solstice, which means that it has the sun reach the maximum declination, and so it has the longest day. Sunrise and the sunset times are about 5 a.m. to 7 p.m. Then for the middle line is an equinox. Equinox is when the sun crosses the celestial equator, when the day and night are almost the equal length. Sunrise and the sunset times are almost at 7 a.m. to 7 p.m. And for the bottom line is the December solstice. December solstice means that the sun has reached the minimum declination, and so it has the shortest day. The sunrise and the sunset time are around 8 a.m. to 5 p.m. Next.
The latitude. Yeah. The latitude of Beijing has resulted in a lower solar angle. In order to have more sunshine time inside the building, the minimum sunshine distance has become longer. This has caused the building distance in Beijing to not to be too high. So Beijing does not have dense buildings like Hong Kong, because Hong Kong is closer to the equator, so the minimum sunshine distance can be small. In this picture, we can see the A is the location in Beijing, B is Hong Kong. The angle in Beijing is very small, so the shadow is longer than Hong Kong. So the building have or longer distance. Next.
Okay. All right.
And also the light pollution in Beijing is really serious. As of last year, more than 70% of the high-rise building of 20 to 50 floors in Beijing have adopted glass curtain wall, all with mirror effect, resulting in light and heat pollution around the building. Sometimes it can be caused birds to crash into the building and die. Like all big cities, Beijing is brightly lit at night, which is almost no stars.
All right.
Okay, next.
And now I will present about the building that how they use the natural lights to work on, and also how they fight against the negative effect of the natural lights.
Okay.
This is Lisa Soho in Beijing City.
Mm-hmm.
Lisa Soho offering varying views thanks to the twisting sculptural form, resulting in a fantastic new civic space for Beijing that is directly connected to the city's transportation network. The atrium brings natural light deep within the building, acting as a thermal chimney with an integrated ventilation system that maintains positive pressure at low level to limit air ingress and provides an effective clean air filtration process within the tower's internal environment. Lisa Soho's advanced 3D beam energy management system monitors real-life environmental control and energy efficiency. This system also includes heat recovery, from exhaust, air, and high-efficiency pumps, fans, chillers, boilers, lighting, and controls. The tower incorporates water collection, low flow rate fixtures, and grey water flushing, as well as an insulting green roof with photovoltaic array to harvest solar energy.
Okay, good.
And this is the building material of the Lisa Soho, the close view of the window, and the heatness in the building during different seasons.
Nice.
The close-up view of the window, you can see the glass of the Lisa Soho. They are actually using glazed window, and it's normally single layer and double layer. And the glazed window, they have coating on it. The coating works by reflecting heat back to its source. In the summer, a low E coating will help block the heat from the sun from entering the building. And in the winter, the coating will help keep the heat in the building by preventing it from escaping through the window. As you can see, the heatness of the building during different seasons. From the left, it is in the winter. The heat will be captured in the building to prevent the building from overcoat. And from the right, the building will remain will maintain the heat. The below will be colder and the upper will be warmer.
All right, good.
That's all from us, so thank you.
All right. Very good. Very good. You need to add a little bit more the map location of the Beijing. It will be very good if you have that.
Okay.
And you have the general temperature. You don't have, right? Temperature of the seasons. You have the.
Don't have, sir.
But you have the time.
Yeah.
You have this. This is good, but general temperature. You can
Need the table.
Yeah.
Right. Okay, sir.
And then the effects of this one is very good. You do comparison with Hong Kong. I wish it could be more detailed, but I think this is okay. You just focus on the Beijing. When you do this comparison, it means you understand what's why they are different. Okay. And then this building light pollution. This is very good. This shows that problems that are happening in the Beijing, and they are quite hard to handle at the moment. Because the building is still there, they cannot do anything else.
Yeah.
They have to. And this example of Lisa Tower is good, Lisa Soho. I also like if you can have different building type, like a small house or smaller building, based on the orientation.
Okay.
Yep.
Thank you, sir.
Overall, there is very. Okay, so good. We can move on to the next one. In terms of timing, also okay, not too long. Next would be Muhammad.
Thank you, sir.
Hi, sir. So can you see my screen?
No, not yet.
No.
I don't see.
Still not?
Okay, I think yes. You can.
I have to proceed.
Yes, proceed.
Okay. Today we are gonna do a presentation about natural light effects in architecture regarding the New York City. We are Muhammad and Nazira. The topics that contains on this journal is effects of natural light and the layering objects and small conclusions.
Okay.
Effects of natural light in architecture in New York City. In architecture, natural light is like the air of life for a space regarding New York City. For a space regarding New York City, some path is actually running from the east to west, as it is shown in the above image. In New York City and everywhere, the special change of the natural light that happened due to the sun journey through its path lets the person to feel and expect what is the time. New York City buildings are designed with the sun in mind to take the advantages of providing the buildings with a natural light, because natural light has its effect, and focusing on natural lights enable the one to create a space which feels much bigger and comfortable than its parts which are artificially lit.
Okay.
And the term is for Nazira.
Hello.
Hi.
And New York's buildings orientation is responding to the sun path because the sunrise is in the east and sets in the west. Most of the New York buildings orient towards the north direction to avoid direct sunlight and show, as shown in the above animation. The orientation of the building affects the percentage of solar radiation for the size of building, and thus the total solar radiation gain of the building. And the orientation of the most buildings in New York is towards the north direction. What I think it's repeating.
No, it's not repeated.
No?
Yeah.
The orientation of most buildings in New York is towards the north direction, as is shown in the above animation, and the sun comes behind the building. New York's buildings are orientated like this to make them don't get direct sunlight, and the windows are always large, thus reducing the need of artificial lighting.
Okay.
And about the learning objects, from this topic, we know how we can use natural light to reduce the pressure on conventional electricity supply system, and how we can design window and opening for better lighting, and also how to use natural light applying technology. As a conclusion, a building is not only designed to look aesthetic and functional, but also to provide a comfortable environment within enclosure. Sustainable solution. Sustainable solutions are more appropriate by the world to provide this comfort to the consumer. Architecture get a new rhythm and language by the influences of the natural light to the design. And that's all.
Okay. Muhammad and Nazira, I believe you already noticed your friend presentation. You can add more info, okay, regarding the New York City, introduction of New York City. Where is it location? Latitude and longitude. This is in the USA, which different continent, and then you also can give general apa nama tu, seasons, right? They also have seasons, okay? Summer, winter, spring, autumn. What is the time of the year that they receive these seasons? Like you refer to Brian's presentation. This is very good. Also show the time when, for example, June equinox, the solstice, and then winter, what is the timing of morning until night, right?
Okay.
And then general temperature when it is during different season. And some map is good. Maybe map of New York, at least we can learn together where is it location. And then give example of building, how building is work, it's not work, design according to the natural light in New York. So for example, a house, how does it look like? If it is big building, how does the orientation is set? It must be very different from these two. Okay?
Okay, sir.
All right, so regarding this improvement, I think we can redo again. I would like to see the improvement of these three presentation next week. Sorry, during next presentation.
Okay, sir.
Okay, not only Muhammad group, also all three groups. There are some minor minor changes you need to add, right? So please add, okay? Okay, so as of now, all three did well. Jack's group is, I really like what you are presenting. All info are almost there, okay? So, okay, regarding the next presentation, we are going to have in 2 more weeks, right?
Yeah.
Okay, so this, I just refer this again so that you can see our classes. So next presentation from all of you is this noise pollution and quietness level in the city. All three of you choose a very big city, very highly populated. I think all three are metropolis city level in terms of density. Okay, so you start with introduction of the city. Okay, where is it location, the general temperature, general climate and seasons. And then when you talk about pollution, noise pollution and quietness, this is a bit different. You must start with the morning until night. What will be the noise pollution and quietness in the city? Most of the time it is quiet noise because of, in general, because of people go out for work, right? So a lot of vehicle. And then some of the city have trains also contributing to the noise pollution. And then quietness level, when it is quiet. Okay, this noise and quietness, the nature of to measure is actually using decibel. All right, I hope you guys take note of this. So decibels is the way to measure quietness or noise. Okay, means the measuring the sound. So you can see the differences from noise to the quiet. What is the decibel in terms of differences? And then besides that, if there is a sometimes it happen to have festival or public holiday with a cultural event, for example, maybe the noise level will be different. Okay, so you might like to add that also. Okay, New York will have a different festival compared to the Beijing or Abu Dhabi, Dubai. So it's different. So you need to take a look at it. and then the noise effects to the human. Okay, noise effect to the human is general. Okay, effects in short term and long term. Okay, there are two types of effects that you need to find out. Okay, noise effect to human is not necessary to be people in Dubai or in Beijing, but in general also can to anyone. Okay. Oh, and then don't forget, when it is about noise pollution, find the contributor. What is the contributor of this pollution? Okay, so far, do you understand the expectation of the presentation?
Yes, sir.
All right.
Yes.
I hope you can improve the presentation of today's one. You just improve it and then show to me in the next presentation, which is 4th of November. All right?
Okay, sir.
All three.
Sir, are we using the same city, sir?
Yes, same city.
Right.
City, Dubai,
Beijing and
Beijing,
New York.
New York, yes.
Okay, thanks.
So I really hope all of you learn something new. But if you, for example, one of you do different in terms of latitude, maybe one of you, for example, chose a city or a country that is on the southern hemisphere, like Chile or Argentina or Australia, right? So the sun path is very different, and then the solstice, equinox also different timing. Then you can see very different in terms of information. Okay. So we still have time, so we shall continue with our lecture. Okay.
Sir.
Yes.
Do we need to submit our slides?
Okay. Alamak, I just closed the. Yes, you got to submit the slide, but it's not. Sorry, not this one. It's not now. It's not tomorrow. It's
very long.
at the end of the after.
Yeah, need to compile.
Yes. Good. Alamak, let me show. Let me open again the slide.
So for the noise one, we need to pick a event, right, and compare the sound from normally and the event, right?
Okay. One is general every day, and one would be the maybe you have festival or event.
All right.
Yeah. Because it would be very different in terms of pollution. Okay, let me share again this one. Okay, I'm shown here is the 2nd of December compilation submission. Okay, so this compilation is compilation of the three of these three slides. Okay, Nash, can you get it?
Yeah. Okay.
So the compilation is to be done individually. Okay,
yeah.
Individually. Then format is SEGI format, no problem. I can then if there is a comment from me, then you just add to the content, and then you also must add this what you learn from the topics given. Okay. And then yes, besides that, you can also add creativity and aesthetics. Also, I also have a little extra marks there. Maybe you can do something more interesting. You can add video as part of your presentation to explain, to show more things. You can. Okay. So for the first time you do this, probably you haven't done this in a long time. presentation, verbal presentation. Some of you need to polish up your pronunciation. Okay. So hopefully you learn a lot more later. Okay, so the presentations all are done in just enough, not too long. Okay, so more questions? Nash, you have more questions?
No, sir.
No. Jack, you have other questions? Muhammad?
No, sir.
No, sir.
No. All right.
So here you go. For the
Okay.
noise effect to human, do we need like do we comparison to other places or doesn't?
Noise effects to human, you can do general because it is same, almost same to anyone.
Okay.
Yeah. So noise effects, they are sometimes you can add sources of noise effects. Sometimes because of work, sometimes because of exposure to certain thing lah. Maybe suddenly there is an airplane crash beside you, so there is a very big noise, and then you deaf one side. Sometimes it happen that way. So there are many cases.
Okay, sir.
So you can add any kinds of sources of noise. Noise sources is a lot, but for the general, in general on the city, you may list a few. Maybe certain noise from car, how much the decibel, from the train, how much is the decibel, from people talking and make noise because of festival, there must be different decibel. So you can learn from this also. All right, I guess that's about it, right? Since no more question, I can continue with lecture. So now when I give lecture, it's much easier to relate with your city. We are still in the light topic, still in the light topic. Now we are talking about climate. Just checking. I have done this before or not? These slides. Have you seen these slides before? Not yet, huh?
Not yet.
Okay. Okay, so this is the climate. Definition of climate is the condition of atmosphere at a particular location over a long period of time. It is long-term summation of the atmospheric elements and their variations that over the short time period constitute weather. Okay, weather short period, climate long period of time. Okay, so there is a color here. All these color represent different climate. Atmospheric elements in the climate is solar radiation, temperature, humidity, precipitation, atmospheric pressure, and wind. Okay, wind, there are two things that we need to know, speed and also direction. Precipitation, there are a few things that we need to know, type, frequency, and amount. Solar radiation, we know that it is the source is from the sun, and then what we need, we are learning something new, which is actually how the sun enter into our atmosphere, and then some of it reflected at first it will be reflected by the molecule within the atmosphere. So it have a short reflection. And then in general, most of it will reflect on the surface of the Earth. Okay, depends on what kind of surface. Some of it is the water body, which have reflective elements in water. So that's why it can reflect back to the atmosphere. Otherwise, it will be absorbed into the Earth. However, because of the whole world is already developed, so reflections becomes more because there are more buildings and more reflective material has been installed in the building. So reflections of the sunlight will be more happening in atmosphere. Sunlight bring in also other kinds of wave. Infrared, for example. The other one is ultraviolet. Okay, these two are coming together with the sunlight, but infrared is providing heat to the Earth. So ultraviolet is bringing the other component. Okay, so infrared re-radiated to the Earth means that it is easily radiates whenever the Earth already absorbed heat from the sunlight, so it will re-radiate it. And the other thing is the waves also being reflected by many materials and then absorbed into the atmosphere. So all the molecule in the atmosphere also able to absorb the heat from the infrared. Above the atmosphere is actually space. Space, there is no atmosphere. There is no limit. If there is infrared pass through the atmosphere, then it is will be disintegrated, dissipated in the space. It will not come back. It will not have more energy. The energy will be reduced to zero. Okay, so what's this? This is example of Africa flat plate tilted at the latitude. Okay, so this is actually showing us a model estimate of monthly average daily total radiation using input derived from the satellite and surface observation of cloud cover, aerosol, optical length, precipitable water vapor, albedo, atmospheric pressure, and ozone sample at 40 kilometer resolution. So here we can see the amount of radiation absorbed into this Africa continent. So with the color yellow, the absorb is less compared to the color darker color. Darker color absorb more. Okay. Temperature. This is the components in the climate. The definition is degree or intensity of heat present in substance or object, especially as expressed according to a comparative scale and shown by a thermometer or perceived by touch. Meaning that if you touch exposed steel railing that in the balcony, the steel railing will be hot, right? If it is in the direct sun from in the afternoon, for example, it will be very hot. You will, you will jump. You touch a very hot steel, and you might be jump because of too hot. You will get shocked because of that. But if it is cold, you react slower compared to the hot. But in terms of pain, is different. Pain from the heat. Sometimes, if it is too hot, you may have boil at your skin. But if it is too cold, then the skin become also become pain, but it's different. Okay, so this is the annual global temperature change in the many years. We can see here in the 1800, the difference in terms of temperature, and then it keeps rising. In the 1940s, it increased quite a lot, and then it's reduced back, and then I don't know when is this, they start climbing again, and then the climb of the global temperature change didn't stop here. This is 2000 sorry, and probably 2020 is already beyond 2 degrees Fahrenheit. Okay, so this anomaly in degrees Celsius means that the temperature, general temperature in the shown here in March 2017. So all these are having different climate, different effects to the countries. Humidity is something actually unique, a quantity of representing the amount of water vapor in the atmosphere or in gas. So we know that atmosphere have also water vapor. Water vapor actually come from heat that, for example, the sun heat the lake or the sea, so it becomes some of the water will evaporate and then evaporate to the atmosphere. However, when it is night and then change to morning, this is the twilight zone timing, where the suddenly the temperature is changing too fast. When it changes too fast, the water vapor becomes dense, and that's why it can turn into a very thick mist like this in the photo. Okay, so average relative humidity. Relative humidity is different from one place to another. It's because of the location nearer to the sea. So nearer to the sea, it is shown here higher humidity compared to the one that is further from the sea. Much further from the sea, it becomes less humidity. Okay, so for example, like here is 35, this is 25. Why it is higher, lesser compared to this one? It's because this is on the higher altitude. And then much nearer to the sea, you can see that the color change to become between 50 to 70% humidity. And then the one that close at the facing the seashores is already 80% of humidity. Precipitation, water released from cloud in form of rain, freezing rain, sleet, snow, or hail. What is hail? Some of you didn't know. Some of you, only very few. Nobody know hail? Hail is actually raining ice. You will receive ice, very tiny ice cube. In Malaysia, in Malay, is called hujan batu. But in English, it's like a small ice, about this size. Then it falls on Earth, and then it's actually not is ice. Raining is not like snow. Snow is very different because it's like snow is very different from the hail. Okay, hail can even drop as big as one fist size. If it happen to drop at this size, fist, even cow can die. Even some big animal hit by this hail can die also. Even cars that hit by this fist size hail will broke into, I mean, the glass shatters, the cars are broken. Yes, it can happen. So I also have experienced hail before. Have you anyone experienced hail or snow or sleet?
Nope.
Even Jack, don't experience.
Yeah, it's happened in China.
China receives snow.
Snow. I think it's every year happening in China snow, but it's really small.
Is it Beijing or Shanghai?
Beijing.
Beijing. Shanghai don't have snow.
I don't know. Shanghai maybe not. It's because Shanghai is hotter than Beijing.
What about Nazira? I believe you are from Moscow, right?
Sorry, can you repeat?
Nazira, you are from your country?
Kazakhstan.
Kazakhstan, sorry. I thought you are of Moscow. I'm so sorry. Kazakhstan is also experience snow, right?
Yeah.
Interesting. So difference snow and hail is very different, right? But I don't think many people experience hail. I experienced once, but I was not in Malaysia that time. I was in UK. Malaysia also experience hail sometimes, but only a few places in a very small place. It's not going to happen in the whole state. It's not going to happen that way. Okay, so move on. This is an example, average of annual precipitation in, this is Europe. The darker blue would be higher precipitation. Atmospheric pressure is the force per unit area exerted by atmospheric column, that is, the entire body of air above the specified area. It is known as barometric pressure. The units is mercury, pounds per square inch is in PSI. So atmospheric pressure is something like this. I believe some of you have experienced when you take off in the flight, where you suddenly felt that loss of pressure in your ear. So that is the pressure change. And besides that, you also, because you are walking on the land surface, you don't felt that much. But sometimes if you take up on the lift elevator that is actually moving quite fast, and then you are going like more than 20 stories, you also will feel air pressure change. Some people call it G-force. All right, and that will make your ear ringing a little. So that change actually can be easily cured by swallowing more saliva, or maybe you can inhale more air. Okay, so next would be wind. Definition: the perceptible natural movement of air, especially in the form of current air blowing from a particular direction. Not all countries have this air speed, air wind, how to say this, wind that is strong, that you can generate electricity. Anemometer is the instrument that measure wind speed and wind pressure. This is Robinson cup anemometer, the old one, the old method to calculate speed. And then now digital anemometer has been developed, which is very small. At the same time, you can check speed. Daylight is a combination of all direct and indirect originating from the sun during the daytime. The total solar energy received from the surface of the Earth, only 40%, is very visible radiation. The remainder 60% is ultraviolet and also infrared wavelength. You can see here. Infrared is here, ultraviolet is here. And then X-ray and then gamma ray. X-ray, gamma ray is different. Factors that influence daylight: sun path, sky condition, season, solar elevation angle. Definition of sun path is a visual representation of the sun range of movement across the sky at the geographic location specified for the project. So we already learned this together. You already know the difference. This one is the longest line, right? And then the shortest one is at the bottom. Most of the time this way. If it is Australia, for example, then all the sun path is actually on the above. Factors that influence daylight: sky condition, the cloud parameters that estimate or measured by weather and observers. These sky conditions are defined by function, also depends on the solar altitude, even the sun is hidden. Okay, so there are sky conditions like this: sunny sky, clear sky, partly cloudy, cloudy, overcast. So they are all have different things. Sunny sky is no cloud at all. Okay. Clear sky is with 30% or less cloud coverage. Partly cloudy, between 30% to 70% cloud coverage. It can be combined with sun in some cases. Cloudy, the sky has more than 70% cloudy cover. It's normally exclude the sun, means the sun is not visible. Next is overcast. This sky has a completely closed cloud coverage, 100%. Obviously cannot be combined with the sun in a meaningful way because the sun is already hidden by the cloud. This is the sky condition that are applied in the daylight factor calculation. And then also this you already know when the cloud is already covered 100%, a big rain is coming. So when it is overcast, then you start to calculate the daylight factor. This is sky condition, clear sky. You can see here less than 30%. Sky condition, this is partly cloudy. Some of the sky. If you can see the sky, these are the most of it is cloud, and then cloudy is between 70 to 30%. Sorry, 70 to 100, and then overcast. This is 100%. With this, sometimes it happens you can just see ray of light coming out, punching through the cloud little by little. So you can see radiates of light coming in. Factors that influence daylight. Season. 4 seasons divided in the year: spring, summer, autumn, and winter, marked by particular weather pattern and daylight hours, resulting from the Earth changing position with regard to the sun. Same photo, different season, you can see different activity, different people coming in and out. And then you can see that the different colors mostly. For example, in the winter, you can see it is fully white because of the snow. But when you can see at the top right, sorry, top left, is the spring. A lot of plants with flowers blossoming. Then autumn, where a lot of leaves fallen, even you can see in the photo. And summer is the favorite time of the year. It's warm and nice to go out. Is it true? The best, favorite time of the year is summer? Or some people don't like summer? In Malaysia, people don't like summer. And eventually, summer is like every other day. So when it is every day become hot, then it's not it's something that we don't like. Okay, so how the factors look like? Is the movement of the Earth according to the Sun. Okay, because our axis is actually axis of our planet is actually diagonal, not straight. If we are having straight, we don't have 4 seasons. But because of its diagonally placed, then the Earth rotation would create 4 seasons to the all Earth surface. Solar elevation angle, also known as altitude angle. Altitude of the Sun, where angular height of the Sun in sky is measured between the horizon and the center of the Sun disk. The height or distance from the surface to the Sun had influence in the illuminance of daylight on the ground. Okay, solar elevation angle, you can see here when you have angle, this is one you can find something like stick, Gaumont is mentioned here, and then the length of the shadow, and then you go and look at the Sun angle according to the shadow. Then you get solar elevation angle. We don't do this in architecture. What we learn is actually the shadow path, shadow movement. Morning, where is the shadow like that? Then evening is different in terms of shadow position. We only learn that. Glare, shine with a strong dazzling light from the sun or artificial lighting. So when you are sitting at the place facing the sun, your eye become hurt, right? And you take photo also, you cannot see. It's total white because of light is actually feel so strong. Even in this photo alone, you feel that your eye is actually hurting because of as if you are seeing the sun itself, although it's only a photo. Is it true? Do you feel this? I believe so. So, direct sun causes glare. That's why in your cities that you chose, all the buildings are facing the north. because the sun is actually on the south, means that at the back, and then the north becomes the front, right? Because all the sun do is giving us glare, so we don't want to face the glare. You have to orientation differently. Effects of glare: bright, different of level of brightness cause discomfort. Occupants may not unable to carry out tasks. So glare is very problematic when it is when you are working or doing something important. For example, driving. Correct? When you are driving, this is the most dangerous time. Is actually when you drive, you are facing the sun, sunset or sunrise. It will happen to you. Sun path diagram. You already know this, so you can learn. You already learned this. Good. This example is from didn't mention here, but when you see this curvature is on the top of the circle, means that it is on the southern hemisphere area. Then you can see the sun path is different. So reading the sun path diagram, the group Jack just now, Brian, Jack, and Damien, they also mentioned about this. This is very important. How to understand this? There is a line. There are three major lines, correct? So from there you can understand the longest time of the year, shortest time of the year, and the average. So here given shown here, longest time of the year, it will have a very deep curve. Shortest day of the year is actually on the shortest line. So it's and then there are also a variation where there is also the sun and the the morning and the night are equal. Application of sun path diagram to the building. Building design shading. Okay, so design shades comes in every type. Pattern, design, based on your idea. Okay, there are so no limits of design. You can design with like this, 8 crate style, or vertical or horizontal louvers. You can do. Anyway, as long as you able to shade your building from the sun direct glare, you will be fine. So those are the references. Thank you so much. Okay, any have questions regarding the lecture just now? No questions. I need to take a break. My throat is already very dry. Okay, we shall continue this topic again. Daylight. Daylight is already, we all know that daylight, they are comprised of sunlight, reflected and reflected lights. Reflected lights, there are two types. Number one is indoor and another one is outdoor. And then there are also other types of daylight, which is direct sunlight and also diffuse skylight. Reflected light also have depends on the where it is reflected. Reflected on the ground, reflected on the snow, reflected from the other building, reflected from the water body, or reflect from other elements. Sometimes it's a natural element, sometimes it's artificial, maybe car or computers, so many things reflected from the sunlight. Daylight factor is represent the amount of illumination available indoor in relative to the illumination present outdoor at the same time under overcast sky. It is used based on the overcast sky conditions only. Also, the most common metric used when studying physical model test day lighting designs in overcast sky simulator. The symbol is DF, the daylight factor. Measurement is percentage. Early version, no need. Static measure, indoor and outdoor illuminance. So as a designer, we only need to understand the sun movement, sun radiation, where it comes from, angle, and then also have to know time of the year. So with that, you can precisely design a building based on the data. We don't need to do so much calculation just to understand about natural lighting. You can do with a proper orientation of the building, and you can still maximize whatever necessary, especially daylight. You don't need this to achieve good daylighting. Variables of daylight design variables. Shape and orientation of building. This is number one. Very important. Number two, characteristic of site. Number three, characteristic of facade and roof. Then, size and placement of opening, glazing, and shading system. Lastly, geometric and reflectance of indoor surfaces. Daylight analysis using Autodesk Revit. So with analysis like this, you first of all put your sun based on your solar angle, and then you decide what day of the year, what time of the day to show the difference. For example, like here, showing is morning, and then the building is oriented that way. So it is when you pass the line, it will be on the other side. And when actually by doing so, you can see that the minimum length. Okay, the building is triangle, right? Basically triangle. Minimum length at the west and east, right? So here is west. It's only, okay, example 10 meter, and then on the east slightly less, probably 8 meter, and then the length probably 40 to 60 meter. So this didn't stop here, because there are also other building factor. Other building factor is also can be determined if this is the angle of the sun. Then if there is a big building in the morning that hiding, disallow the sun to pass the building, then you will have a very big shade from the building onto the side. Aims of daylighting condition. Average light for illumination. Provide a comfortable environment for building occupants. It also create ambience and promote mood. Visual comfort is also very important in daylighting design. Ability to see and move, and then avoid eye strain. Next would be fulfill visual need. Balance between intents of light, location, and direction. Next would be suitable to perform visual tasks. Visual tasks is almost everything lah, but to be more specific, perform visual tasks is, for example, like cooking. You need visually control your food, or maybe working, you need to see the keyboard of the computer or laptop to work on, or you want to write or draw in the book or in the paper, drawing paper. That's an example for performing visual tasks. Type of daylighting, top, side, and then direct or indirect. If it's needed to have artificial, depends, because most of the time artificial lighting will be used in the night, where there is absence of the sun and daylighting. So besides this, there are systems to control the sun from giving a direct light from the sun, especially for example in some of the cities in the north, some of the cities in the south. Depends. Shading device, they have two types. Number one, installation, which is fixed only, you cannot move. Then some of it can move. However, the system is very unique because it is controlled by artificial intelligence, AI, then to control the sun. Either it is hot. If it is too hot, then you can close fully the system. But if you need some daylight, you can open it, and then the system will help you to get maximum daylight. This is the example. Horizontal is like that. Beginning is like this. And then windows with shading device, simple as this. Full glass, but when you have shading device, you can help yourself manually. But it is the most efficient, because when you need to see a very nice view, you just adjust the angle of your shading device. If you need privacy, just close it fully. Then windows and shading device design based on timber material also can be done. There are many ways to design this. Sunlight control. Opening on the house above is covered with translucent or transparent material that is designed to admit light. There are many examples here, how light well is designed, and then how it is going to measured and then placed on the building. There is a lot of way you need to study. Atrium. It's another important design in architecture, how to appreciate daylight. With this also, they can already save a lot of electricity, require a lot of electricity payment. Sorry, when you have that, there are too many, it's expensive. So when you have this glass, you already can save. Light shelf. This is also a quite interesting method to do. Now, not many architects love to use this as design. It always position half of the thing outside of the building, and then the rest will be inside. The ratio is like 80 to 20, 80% inside, 20% outside. But this material as light shelf is not. Sometimes it's glass, reflective glass, and most of the time it's just how to say this, just a reflective material. And most of the time, reflective material and the best is actually white, because white, it is the lightest color in terms of weight. Clear story. Clear story is have a high ceiling window, reflect on the roof, and then goes to the room at the bottom. Light duct. Light duct is also quite interesting. It's a new technology for houses that is never have a proper direct sunlight or daylight. So you use this. Some of it called light duct, some of it called sun tunnel. Okay, so you can see here it is installed on the roof, and then the light is actually reflected from one another, and then supply light in the house, as if it is look like lamp or LED light, but it's actually just daylight. Monitor roof is where you monitor the building, putting in the roof facing the south. For example, facing the north, then immediately you get. Otherwise, you don't have to. Skylight design. Skylight design is actually important because with the wrong position of structure, the skylight will either don't have at all daylight or can have maximum, but it depends on the designer how you want to do it. Skylight design. This is one of the nicest thing. And then application of daylight system. This is the example. This example is already outdated. Control of direction of sun and skylight. This one, Bahar Towers, Abu Dhabi, and 45-meter tower completed by ES Architect, June 2020. Sorry, 2012. Application of daylight system, for example, like this one, Bahar Towers. This facade is actually alive. They can close and open whenever it is needed. If it is too hot, then it is closed. If it is nothing happen, then they can open the daylight system. It is helping a lot of buildings. Okay, so that's all for the class today, especially topic 5 and 6, topic 4 and 5. Topic 6 is artificial lighting. We will talk about that in the next class. Okay, so do you have questions regarding the class today? So there's no questions? Oh, okay. No questions, huh? Okay, so no questions. I don't know what else needed. Though, yeah, that's all for the class. We shall meet again next week. And then if there is a question regarding the assignment, just request the question in the group, okay? Just if you don't know, tell me you don't know something. At least you don't do a mistake, okay?
Okay.
Okay, sir.
Okay, thank you so much for listening to the class. I'll see you again next week. Bye.
Thank you, sir.
Bye.
Welcome.
Bye, sir.
Bye.
Welcome. Bye.